whenever you have a sparingly soluble salt, so you take it, you take water, you start visualizing and you put it PbNO3 here, PbIO3 2 here. After some time, what will happen is some part of this will dissolve, and this will dissolve and it will convert to Pb3 plus. So let us say S part, S dissolved, S dissolved. It will convert to it will ionize immediately after it dissolves, it ionizes. That's why it dissolves. So PbIO3 2 will dissolve and give you ions. So supposing 5 grams have per some dm cube have dissolved. So you can convert it into moles per dm cube have dissolved. But you will notice if S moles per dm have dissolved, moles per dm, so it will convert into S moles of this, but 2S of this. The moles will be, because this is a 2, this is 2. Achha, now these are the moles of this. These are the this is the molar concentration of this, and they will be in equilibrium with what? They will be with equilibrium with the undissolved, with the undissolved. So this part which has gone has converted into dissolved, and actually now you are having something like this broken piece, and you have an the ions, and there is an equilibrium between this broken piece and the ions. So that is what he's trying to convey here. He's saying calculate the solubility of contain this dissolved in it. Solubility of lead, if 25 of saturated contains dissolved in it. So first calculate the concentration in moles. He's calculated the concentration in moles. 4.4. This is actually so much moles. So these many moles dissolved, and they converted into these many moles and these many moles to double of Cl. So if I substitute these values, I then get Ksp. Then I get Ksp. So see, this has got moles per dm cube, but the unit of this is some other unit. Ksp is some other unit. And this, so this is concentration at equilibrium is this change in concentration is this false, but now there is solid left and this. So there is this is the equilibrium, and the product of these two square is the equilibrium product square. So the square of this. So he says करना क्या था, we calculate the solubility. So this is calculating the KSP. Also calculating the solubilities here. So first he's given you KSP. So he's given you KSP, and from that, once you get the KSP, you have this given. So these two are not given. This is given. So this soluble, this is the solubility. So we get S square here. So S square is equal to 5, and S is the solubility. So we get soluble. So we are getting 7.1 and the mass dissolved. So we could be asked the mass dissolved. We could ask the solubility is moles per dm cube, and the solubility product is different. So in that question, this is KSP is given. He's asking you, पहले to write the expression. The expression would be Pb2 plus IU3 2 minus raised to power 2. This is the product, the expression. Now comes the solubility in moles of this. So I know this is the value of the KSP. This is S and this is 2S. And then you square it. So actually it becomes S into 4S square. It becomes 4S cube. 4S cube is equal to 3.69 into 10 raised to power minus 3. So S is the solubility. So first I divide this by 4 and then I find the cube root of this. This is what you have to do. I'll show you the answer to find the solubility. He the expression is this, and then he divides 2x into 2x whole square. X is cube root of 3, but after you divide it by 4, and that will give you the solubility. Solubility is something else. You see the units, you can also make out by the units. You see this is mole cube per dm raised to power 9. How is this? Because this is 4 into s cube. 4 into s cube. 4 into, this is moles per dm cube whole cube is ksb. So mole cube, and this into the minus 9. So you please be clear, and you'll have to find the cube root. You can make out from the units also.